Alright guys, it's about that time. Have a good day.
I don't know where I'm going. Wait, are you in our bathroom? Well, I'm in Fairfield. Wait, do you know where they are? Drew and Hallie and...
What? Do you know where it is?
I don't know that you lost your egg. Yeah. I mean in math.
It's off Armstrong.
Yeah. But like, do I go to a classroom first?
Yeah. I want to say animal shelter is...
Oh, here we go. Animal shelter is a
Go then.
Okay.
You know how to
Yeah.
That's suspicious.
I was kind of scared. I was like dashing.
I wonder if it'll happen during like sixth period. Caroline, then I'm so scared for Spanish.
Okay, the quiz is not hard. Like everyone else is fine. Like I just am bad.
It's whether you're just not lucky.
Do you know about Chavez?
What?
Chavez?
Yeah, I know him.
Okay, good.
I watched a little. Oh my god, I'm scared. Just gotten oh, but we're just 20. I'm so out of it. Oh, that's true. So because we did that last time. Yeah. That was bad. Wait, did I change it?
Well, I didn't take like the full like dose. Yeah,
I've just been going along with pace. My number something like 35.
What? Something. Yeah. Well, we did.
You're supposed to say it was super bad.
Yeah. Oh yeah. She did a 3-1.
Anyways, you really want mine now. Oh no, it's okay. I just don't have the
And I guess what? The 21. Oh, Oh no, I have no on it.
Okay, so it's still me whenever you're working on that. If there's a circuit morning.
No, I have one to
Everything right now. Mr. Finish is sitting out. I was like, it took so long. Are you gonna order?
Are we talking about your bake sale?
Yeah.
Okay, if y'all did not give me assignments 21 and 10 last class that I asked for, this is your last chance to still get full points on them. So, if you didn't give them to me last time, it's your last chance for 4 points, unless you were gone.
Wait, oh my god, yeah.
Did you win? Oh, you could actually I know. For my power prices, so we only choose winners.
Okay, nobody else? Okay. So first off, before I get into classwork stuff, I think there was supposed to be a drill this morning, and typically that happens during advisory because if it happens right now, it messes up some people's lunch. Okay, never mind. We looked at the time wrong. It's this afternoon. So you'll have an intruder drill in one of your afternoon classes. Okay, so that doesn't matter. So class today is going to be pretty similar to what we did last class. So last class we did a circuit on power rule to get better at rewriting those and get quicker and more confident on power rule. So today we're going to start off with a circuit that focuses on product and quotient rule. Now I'm going to get you started, remind you of the direction since it's the second circuit of the year, and I'll go over question 1 with you. Like last class, I think you should be able to finish this up in class since this is the first thing we're putting our focus towards. So I would like you to give it to me if you have it done. I guess if this is more of a struggle for you than other people, I guess you could do it for homework and give it to me tomorrow. Keep in mind tomorrow is a B day. This is a B week again. So that should be roughly the first half of class. And then finally, the second half of class is to finish up that long book assignment. This is a third class period. I've given you some time to work on it. And if you've been keeping up with the benchmarks I've been setting for that, I think you should only have like 8 or 9 questions left. But that is opened up in Google Classroom. I will ask for that one tomorrow. Most of our assignments I put in as 10 points. Pretty much most assignments are about worth the same. But sometimes when we have really short assignments, I might just do a 5-point assignment. And likewise, if it's a really long assignment, I will try to give you more points to make it fair. So with the book assignment being as long as it was, that will be a 20-point assignment. So just make sure that you have it finished, not missing anything, and you have checked your answers. Okay, so with the product and quotient rules circuit, first thing I'm going to suggest to you, and this is optional I guess, but both of these have a formula with them, so might be a good idea to just write them down on the top of your page here. Now I think if you look in your notes, you're gonna figure out why I'm gonna suggest this, but in your notes, don't write this down yet. In your notes it talks about F and G, and it says something like F prime G plus G prime F, and that's okay, but I'm going to refer to the formula as U times V, partly because this is a little more condensed. If you want to take the derivative of U times V, you need to take the derivative of U once with V left alone, bless you, and then do it the other way. So you should be getting more and more familiar with that because you've been hopefully practicing that on the book assignment as I asked. That's not that important for product rule, but if I do the same thing with quotient rule, I'll point out to you why I think that's a good strategy. So again, if you strictly go to your notes, it probably says f of x over g of x, and then for the quotient rule it's going to say f prime g minus g prime f over g prime, or g squared, sorry, not g prime, g squared. The problem with thinking of this in terms of f of x and g of x is sometimes you're going to see questions where like this one. When you get down to this one, f is not the numerator and g is not the denominator. Those are switched, so you can't apply it exactly the way it looks on your notes. So that's where I would say the u and v is just a little bit more straightforward. If you want the derivative of something divided by something, call the numerator u, call the denominator v, and then you should be taking the derivative of u times v minus u v prime all over the denominator squared. I think that's a better way to write the formula, because then it doesn't matter if it's talking about f of x on the top or the bottom, or g of x on the top or the bottom, or h of x, and then the formula doesn't say anything about h of x, and then you don't have to try to make adjustments there. So I would suggest considering thinking about the formulas in this way. Okay, and then just a quick little reminder about how you should approach a circuit, and just a quick little reminder about what we're doing here and what you should find challenging and what you should not find challenging at this point. But the very first top left question is always going to be question 1. The directions ask us to take the derivative here. So glancing at this, I see something, which I'll call u, times something else, which I will call v. Also optional, but I would say that since you've gone this far through the book assignment, if you don't have the product rule and quotient rule memorized yet, it might be a good idea to make yourself write it down every single question, just because that repetition is going to help you remember it. You don't have to do that for your homework grade. But take the derivative of the first part, so you have to be able to do the power rule here. Know the derivative of the constant is 0. Leave this part alone. So that's easy enough. Product rule has a plus, quotient rule has a minus, so be careful about that distinction. And then it says leave the first part alone. So just copy it down. Times the derivative of the second part, which once again, you've got to be able to do power rule to get 3, and know the derivative of the constant is 0. So technically this is the derivative, but honestly taking the derivative is the part that should be getting to be pretty easy for you. You follow the pattern, you have to know the derivative of the constant is 0 a million times. You have to be able to do the power rule a million times. Sometimes you need to know the derivative of cosine, sometimes you need to know the derivative of sine. There are some that we memorize, but generally the tough part is going to be the simplifying. Now, not exactly question for question, but overall the questions tend to get harder the further you get in the circuit. So this one is one of the easier ones to simplify, because you really can't do too much besides distribute the 2 and distribute the 3 and combine like terms. So, and of course simplifying can be more of a pain than that. I think there's a question or two in this one you've got to get a common denominator. I think there's a question or two you're going to have to use some trig identities. There's a question or two where we're going to have to use exponent rules. All the same type of algebra stuff that has been showing up will continue to show up in this. So now that I know the answer to question 1, 12x minus 1, if none of these boxes have that as an answer, then you know something's wrong. But if any of them have that as an answer, that's probably question 2, and you probably should do this one next. Since they are supposed to build up in difficulty, it kind of makes sense to try to do them in order. So, of course, this one would need to be the quotient rule, and then you keep on going. And then eventually, the very last question, once you work it out, it's supposed to give you the answer that loops back to question 1. So, if every one of your questions has the answer listed and the last question loops back to the first answer, then all of your work should be fine. It would be very, 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 very unlikely that that would that you would have wrong stuff and that still happened. Okay, so go ahead and run with that for a few minutes. So try to do a few questions here. Like last class, I will try to be a few questions behind you. So in about 5-10 minutes, I will offer to help out with any of the first 4 or 5 questions. And then you can keep on going at the pace that you're at. And then as you finish it and turn it in, you can go and finish up the book work. So hopefully you don't have any homework. Okay, so go ahead and keep going, please.
I finished the first one.
Oh. Okay, you can take it tardy if it's an emergency, or you gotta wait 10 minutes.
Well, it would be 3 minutes because technically 2 minutes. Because technically we started at 40. What time did we start? 45 or 40?
35.
But it's 48.
Okay, then you're fine.
So we're good?
Okay, I know it's still pretty early, but again, if there's something that you're missing in the first few questions, you're going to have the same issue later on. So, is there any of the first, I don't know, 4 or 5 questions that you've gotten to that I can help with? Number 3? Okay, which one is number 3? Back page.
The second one to the bottom, to the right.
This one?
Yeah.
Okay. Okay, if you need help with question 3, go ahead and follow along with me. Otherwise, keep going on your own. Bless you. Okay, so when I glance at question 3, I see I've got something, x squared, times something else, cosine x. That's how I know it's product rule. If I did not have the product rule memorized yet, I would force myself to try to write it down. And then check it to make sure that I'm memorizing that correctly. And then this is telling us what to do. So take the derivative of the first part. So for that, we've got to be able to do power rule times the second part left alone, plus, now leave the first part alone, times the derivative of the second part. And so for this, you have to have this one memorized. The derivative of cosine is negative sine, so that plus is going to become a minus. And this is the function y equals, this is the derivative, so y prime equals, and technically this is the derivative, but I suspect that they're going to at least factor out an x, since they both have an x. So I would start looking for the answers that looks like that. Oh, so top left of the back page.
Yeah, I saw it was a mistake.
Okay. Okay. Anybody else have something further about number 3 while it's up there? Okay, Birdie, which one are you on?
Can you do number 6?
Okay, which one is number 6?
It's on the front page, right one and down one.
This one?
Yeah.
Okay. I will, but let me give everybody a couple more minutes to get there, because I think this is one a lot of people will need to ask about. So just work on a random question for a minute while you wait. So again, a couple more minutes, and I'm going to do question 6 on the board. I want to give you all time to get there and try it on your own first. Has anyone not made it to question 6 yet? That's fine if you haven't, I just don't know. Okay, so I will look at question 6. So question 6 is definitely going to be quotient rule. It's something divided by something else. So quotient rule says take the derivative of the numerator, which would be 0 minus sine x, times the denominator left alone. Just copy it down. Minus, product rule has a plus, quotient rule has a minus. Now take the derivative of the denominator, which would be 0 plus cosine, times the numerator left alone. Just copy it down. And then one of the biggest mistakes students make at this point in the year is they get lazy about the denominator, and then on FRQs, you're not in the habit of putting it. It's over the denominator squared. So make sure you're writing that. Now, again, technically this is the derivative. Sometimes that's good enough. For this question, we need to get it to match up with one of our other answers, so we need to deal with the simplifying. So, are you okay? Oh, Brody, this was yours. Are you okay with the derivative part?
Yeah.
Okay, so the simplifying, again, the simplifying just gets easier over the year because we just keep practicing basically the same stuff. But I'm going to suspect that they probably leave the denominator alone just because there's not too much you can do with that. The numerator, we could distribute this negative sine x and distribute this negative cosine x. Okay. Did you get that? Okay. And then you got stuck. Okay. So for a lot of people, so y'all are my last of my AB classes. I have a AB class on third period 8 days and then second period this morning. But so we have to keep on going here. Now those of you that skip pre-cal, the disadvantage you're at here is there is a identity that you have to know for this question. If you did do pre-cal, you're very familiar with it. But sine squared of any angle plus cosine squared of the same angle equals 1. You need to have that memorized so that not only can you tell me that, but you can recognize it. When I look at this, I see I've got a sine squared and a cosine squared. And so instead of saying positive sine squared plus positive cosine squared equals 1, negative sine squared, which is what I've got here, minus a cosine squared, which is what I've got there, what would that be equal to? Negative 1. So again, it's not that like jumps out at me necessarily, but when my answer doesn't match up and I have to dig deeper to try to figure out how to simplify, those two that are highlighted can become a -1. And without knowing that and being able to recognize that identity, then you're stuck for that. Okay, and then the only other thing they did for their answer is every one of these numerators terms are negative, so they just put the negative out front. They basically factored the negative out front. So anytime you see sine squared x plus cosine squared x, it's 1. In that case, negative sine squared x minus cosine squared x would be negative 1. Okay, again, I don't want to get too far ahead of where the majority of people are, but was there any of the other first 6 that's not matching up? Okay. I'll give you some more time then. I probably said this already, but tomorrow we'll talk about chain rule, which is the last of the derivative types that are unique that you will have to do. So your AP exam expects you to know how to take a derivative in your calculator. You've seen that a couple times. Your AP exam expects you to memorize some derivatives. You guys have seen most of the derivatives you are expected to know. Your AP exam will expect you to do power rule dozens of times. You've seen that lots. Your AP exam will expect you to do product and quotient rule which we're getting better at today, and your AP exam will expect you to do a process called chain rule. The only piece of advice I can give you about chain rule before we do it tomorrow is chain rule is not a different type of differentiation, it's an addition to these. So it's after you do the power rule, you might do the chain rule. After you do the product rule, you might do the chain rule. After you do the quotient rule, you do the chain rule. So if you can't consistently do power, product, and quotient rule, then the chain rule is adding an extra step to make it even harder. So a little more important that you feel as comfortable with this as possible. Okay, let me give you a few more minutes and then I'll interrupt for questions again. Okay. Can I help out with another couple questions? Yeah.
Did you do number 10?
Number 10. Which one is number 10?
It's the bottom one on the left column on the front.
This one? Okay, so for question 10, just at a quick glance, I can see it's going to have to be a quotient rule, something divided by something. So quotient rule says make a big fraction, take the derivative of the numerator times denominator left alone, minus, then leave the numerator alone times the derivative of the denominator. Are you okay with the derivative of square root of x being 1 over 2 square root of x?
Oh, yeah.
You don't need me to show you where that comes from? Okay. All over the denominator squared. So square root of x squared is x. Now, hopefully this is where you guys start to see how things will eventually start to become a little bit easier. Because I would say this is good for the derivative, but there's zero chance this is what it's going to look like simplified. Because this is, we've got a small fraction within a big fraction. That's a complex fraction, and complex fractions are never considered simplified. The good news is we get to handle this the same way we handled it back in our limits unit. I would love to multiply this by 2 square root of x to make those cancel. And that is mathematically legal as long as you multiply everything by 2 square roots of x. So right here we get a 2 times a 3, which would be 6. Square root of x times square root of x would be x. Over here those two cancel, so we're left with a minus 3x plus 7. Make sure you distribute that. Minus 3x minus 7. And then in our denominator, we've got a 2, an x, and a square root of x. And I think this is what the answer looks like after you combine these like terms. 6x minus 3x would be 3x. So that's where I would start looking for the answer. Yeah, there's one that looks like that. So my guess would be either you might have had a mistake taking the derivative of square root of x, or you forgot to multiply them all by that to get rid of the complex fraction. So, yeah. Number 8? Sure. Which one's number 8?
It's the one right across.
This one?
Yeah.
Okay, this one is actually one of my favorite questions because there's a lot for y'all to learn out of this question. Okay, so for question 8, they want us to find the derivative of tangent, and they give us a hint. So there are some later questions that basically want you to do the same thing, but they'll take away the hint. They won't give you a suggestion. So if you skipped pre-cal and you don't know that tangent is sine over cosine, you need to learn that as soon as possible. But rewriting tangent as sine over cosine allows us to do the quotient rule. The derivative of the numerator times the denominator left alone minus the derivative of the denominator times the numerator left alone, all over the denominator squared. So there's our derivative, but cosine times cosine is probably going to be called cosine squared. Sine times sine, they're probably going to change to be called sine squared. And then so one thing I like about this question is this is already the second time today that this has come up. Sine squared x plus cosine squared x is our first Pythagorean identity. That comes out to be 1. In fact, you still have that on your desk by your seat number. So if you don't remember those, you can glance at that during class. And 1 over, what is 1 over cosine the same thing as? That's secant. So 1 over cosine squared would be secant squared. There's the answer to the question. Now, that's totally legitimate. That's fine to do this. You're supposed to know tangent is sine over cosine. You're supposed to know how to do the quotient rule. You're supposed to recognize sine squared x plus sine x, cosine squared x plus sine x squared x is 1. You're supposed to know 1 over cosine is secant, so 1 over cosine squared is secant squared. All that being said, in this question, I hope that there's not too much longer before y'all can just go straight to this. The derivative of tangent is secant squared. How could you have possibly known the answer to that was going to be secant squared?
It's one of the
Yeah, so I actually well, I'll find it eventually. Okay, there we go. Yeah, so number 19 on your handouts. I said at some point you're going to want to memorize the derivative of the 6 trig functions. You should already know sine and cosine because we use those so much. But the derivative of tangent is secant squared. You're going to save yourself a lot of time this year if you memorize these other 4. So that particular question, if you had that memorized, you can skip the whole rewriting, quotient rule, trig identity. It's a lot faster to just have those memorized. So you don't have to have them memorized yet, but you will need to memorize them before we get to our next test. So. All right, keep going.
How do you write secant of x as a trig function?
Well, if you have your derivatives memorized, it's secant x tangent x and you're done.
Mm-hmm.
Otherwise, you have to change this into 1 over cosine.
Is that the trig?
Mm-hmm. Yeah, 1 over cosine is the same thing as secant.
And then just do the quotient rule.
Uh-huh.
Okay.
Yep. Johnny, you want to put your phone up? Okay. As soon as y'all are ready, Any of the first 10s you're still struggling with? Or 11 or 12? Yeah.
11.
Okay, which one's 11?
Bottom of the page, second from the top, one up right.
This one?
Two above that.
This one?
Yep.
Okay. So the short, this is number 12?
11.
11. Okay, so the long-term thing that you want to do for question 11 is you want to just straight up memorize this. This is one of the 6 trig derivatives. The derivative of secant something is secant something tangent something, and you can be done. So that's what I would suggest to you for long-term. For short-term slash you aren't sure on the test, you've got some extra time, you want to check it, instead of calling this secant, you could call it 1 over what?
Cosine.
Okay, 1 over cosine. And then you can say, all right, I've got something over something, so I could take the derivative using the quotient rule. Derivative of the top times the bottom left alone minus the derivative of the bottom times the top left alone all over the bottom squared. Since this is 0 times, this is just going to go to 0. And so the derivative is sine x over cosine squared x. Now, this is still technically correct, but I will warn you, we don't normally talk about the derivative this way. We usually talk about it this way. So if you split this up, if you put this sine over one of the cosines, that's where the tangent's coming from. And then the leftover would be a 1 over the other cosine, which is where the secant's coming from. So again, you don't really have to derive the trig derivatives for this course, but it's also not that difficult to do those. So.
Can you do the second to last one on the front right column?
Second to last, front right. This one? Okay, this is also a good one to ask. Do you know the number?
I have 12.
This is a good one to ask because this is more, I mean, your AP exam is probably going to have one question that's just straight up product rule, one question that's just straight up quotient rule. Can you do them? Now, you're going to use those for other topics that we're going to talk about later in the year. But a lot of times they ask this stuff, they like to ask it in a weird way like this, where it's not in the format that you have practiced it 100 times. They try to put a little bit of a twist on it. So, to me, I feel like students don't always know the best way to approach this, but this should help you with lots of question types in this class. If you want to know what h prime of 5 is, that's the ultimate goal here. You're going to first have to figure out what h prime of t is, and then just plug 5 into all the t values. So you've got to take the derivative of h, and here's h. I'm nowhere near ready for all of this stuff yet. The derivative of h would be the product rule. I've got something times something. So derivative of the first part times the second part left alone plus the first part left alone times the derivative of the second part. That is the derivative for some generic f of t minus g of t. Then you just need to realize, okay, now that I know the derivative, I want to know when t is 5. And we happen to know f prime of 5 because they gave it to us in the question. I know g of 5 because they gave it to us in the question. F of 5 is right there. G prime of 5 is right there. And then after you FOIL this and combine those terms, you should end up with your answer. So minus 3 plus 14. minus 7 plus 1.5 would be negative 5.5 or negative 11/2, I believe. Is that enough? But again, I know you read that question, it's just dumping tons of information on you. Slow down, do the derivative, same product rule. Product rule never gets harder. Plug in 5, then you realize how you're supposed to plug in all those pieces to get what they want. But if you're trying to use those pieces from the beginning, you're probably going to plug them in the wrong spot. Okay, can we do one more before I give you more time to work? Is there anybody who's not asked a question yet today? Okay, anybody who has asked one, have another one ready to go? Okay, I guess you're not quite ready yet. order of multiplication doesn't matter. So you could either FOIL all this and then distribute the negative, or you could distribute the negative and then it's just whatever you
Would you use the way just be the FOIL it first and make sure?
It's up to you. Whatever, it's easier for you. Alright, how's it going? Okay, nothing specific holding you back? Well, that's one of the 6 that I would recommend that you just memorize. It's negative cosecant squared. The only other way for you to do that. Okay, do you know tangent is sine over cosine? Do you know that one? Yeah. Okay. Do you know that cotangent is the reciprocal of tangent? Yeah. Okay. So you could say cotangent is 1 over tangent, or you could say it's cosine over sine. Cosine over sine. So if you rewrite it this way, you could do the quotient one. But in the end, come out to that. Is it okay? Don't need any help here? Okay, so the quotient rule, I would say G prime F minus F prime G all over F prime. Yeah, sorry, not F prime, but F squared. And then you really want to know at 5, so then you start plugging in all those things. It's going to be similar to this one that we did together. Okay, keep going. If you get stuck, I'll look at what you did.
I'm stuck on this one.
Cotangent? Well, either A, you can straight up memorize it, which is what you'll want to do eventually. But for cotangent, you could change, okay, so you can change it to 1 over tangent. So I'm not telling you that that's wrong. But when you get down to this, it's hard to see that that is the same as that.
Oh, so that just equals this.
It does, but, so what you have, what do you have as your answer so far?
Negative secant squared.
Okay, so instead of saying negative secant squared, I'm gonna say negative 1 over cosine squared. Same thing.
Divided by tangent squared.
Divided by tangent squared, I'm gonna say sine squared over cosine squared. So we got negative secant squared divided by tangent squared. So it's the same thing as multiplying by reciprocal. Right? And then the cosine squared cancel, we left with a negative 1 over sine squared, which is negative 1. Alright. Is there something specific?
I'm just working on it.
So before you start doing any of this stuff, I would just write out the derivative. So that's going to be U prime F minus F prime G all over F squared. I would just write all that out.
derivative of the numerator times the denominator minus derivative of the denominator times the numerator all over to the and then that'll give you the derivative. But you want to know the derivative at 5. So every one of those has 5. So then this will tell you which of these to plug in where. So first you want to prime of 5, which is 1/2. So over to the side, that's a half. And then f of 5, which is just 3. Right, minus, and so just keep plugging in as the quotient. Doing okay?
I don't know why you were holding the sheet now. Soon I'll probably be able to memorize, but I need to memorize those, right?
Eventually, you need to know sine and cosine immediately, but
And tangent, obviously.
tangent gets used a lot, but other three don't use that a lot. But that's gonna, in the long run, it's gonna be less work.
Okay.
Let me see what you think.
I got my other sheet.
Yeah, you put on a sheet of paper.
You have such things already.
So, numerator, denominator,
Okay, and that's all over the denominator squared. So that's all gonna be over there. Now for this question, and just tell you which way to head. So this x to the negative 1/2, this is basically 1 over 2/3 of x. So you're going to have a small fraction here within a big fraction. So that complex fraction, multiply this by 2/3 of x, this by 2/3 of x, and then this by 2/3 of x. And then two-thirds of
Did you know that yesterday me and Allie counted out 479 boxes of crayons? For what? Ambassadors. What is it?
Okay, let's run over cosine.
Like social media. But you also like tell the lady that does service hours.
So 1 over cosine squared is going to be. There you go. Derivative of tangent.
Whoa, you're thinking wrong with another part. I just did the right one. Oh.
You did what you had to do. That's where I'm thinking. If you have this memorized, you're done in 5 seconds. Versus on the test, trying to rewrite it, do the quotient rule, remember trig identity, remember trig identity. It's not that you can't or shouldn't be able to do that, but why did you never have
That is what about you.
Okay.
Doing alright.
Where's your ID?
I lost it, so they just gave me this because they're out. I am a student. I just wanted to make sure they did. I don't know.
How's that? What's your time? Y'all have different ones than us?
It has this.
Yeah, I've got that.
Okay.
But your other end's a clip?
Like one big idea. I don't know how it.
It's like a ring. Huh.
That would be more convenient and less usable.
Well, you just need to still use one of the t-shirt patches.
Let me go back to my car. Back when I parked down.
I need to like
I hate
get
this.
a pen, put it on my shirt.
Did you have the keys?
What I usually do is I like to have magnets on mine, I just wear them in my pockets, but they won't let me do that this year.
My dad's so mad.
They needed to say staff.
He didn't teach me the baby, so that's why I'll
take your
go.
ID, magnet it, and just wear it. You can sew the
How's
lanyard
that any
into
better
your
than
collar.
wearing it?
Sew the lanyard into your collar.
I'm getting like a similar.
I guess I could probably put it in my pocket.
Sometimes I think the counselor will say, I think join the Spanish class.
Are you working
Yeah, I can.
I'm in the Spanish honor society, the science honor society.
Okay, which one is 15?
right above number.
Is that it? Are those all keys? Did I say science? Yeah, okay.
Somebody asked for number 15, so if y'all need help with this one, please follow with me here. Okay, so 15 definitely needs to be product rule. Square root of x times x plus 3 squared. So your derivative should start off with the derivative of x squared, which you might want to do out to the side. Now, I start doing this derivative pretty quickly just because I do it so many times, I memorize it. But bring the power down, lower the power by 1, and then move this to the denominator. So that derivative becomes that times this left alone plus, now the derivative of x plus 3 squared is just the power rule. You can bring the 2 down and lower the power by 1 and you're done, times the denominator, or times the first term left alone. Okay, you okay with that? Okay, so let me rewrite this because I think it gives you a little bit of a hint. Instead of calling this 1 over 2 square root of x, that's the same as 1 over 2 square root of x like this. So when I compare these two, they're probably going to want us to get a common denominator here. So I want this to be 2 square root of x, and I can't multiply the denominator by 2 square roots of x unless I'm willing to multiply the numerator by 2 square roots of x. Bless you. And then now that they have a common denominator of 2 square root of x, I can push them together as one big fraction. This can be FOILed out. X plus 3 times x plus 3 looks like this. This mess of stuff, you need to be careful. You've got a 2 times a 2, which would be 4. You've got a square root of x times a square root of x, which would be an x. And that still needs to get multiplied by x plus 3. So if I distribute that, that would be 4x squared plus 4x times 3, which is 12x. And then finally, we can combine some like terms. We've got some x squareds, we've got some x's, and it's over this new common denominator. And I think that's all they did.
Thank you.
So one in the top right. Anybody have another circuit question ready to go? 16. I know which one 16 is. Okay, so for question 16, I can actually give you a second way to do this tomorrow. Once you know chain rule, there's an option on how to do this one. But for today, your only way to do question 16 is to think of cosine squared as cosine times cosine, so that you can do the product rule. Derivative, not the derivative, plus derivative times not the derivative. So you end up with -2 of these things. They're sine x's, cosine x's. Was that all you needed? Okay. This is for me, but I'm just really tempted to show you the other way to do this question. What tomorrow's topic is going to be, I just want you all to see this for just a second. Cosine squared means cosine times cosine. So same thing. I'm going to show you tomorrow this thing called chain rule that you have not had to worry about. But basically you can start this question off the same way. You can do power rule. You can bring the power down, lower the power by 1, and then what we'll talk about tomorrow is chain rule says you have to come back and then multiply by the derivative of anything in the inside. And what's the derivative of cosine?
Negative sign.
Negative sine. See how it's the same answer? So, once you know chain rule, or once you get used to that process, you have that option to do that. But that's for tomorrow. Okay, I know some of you guys are getting close to finished with this one. Remember, I do want you to go ahead and give it to me so I can grade it and give it right back to you, and then you can use the rest of the class to work on the book assignment. If you don't get all the way finished with the book assignment in class, remember all of those are worked out on the website, so you can get the help that you need from those. The circuit has some questions worked out on the website, but you need to make sure you ask the ones you need help on if you've got class time.
on 20?
You gotta finish the whole thing.
Like, was there like 120?
It was starting at 3 up to 118.
118.
Yeah. It's not every question, it's just those that I had up there. That's on the agenda still. Alright guys, we're down to about 8 minutes here, so let me remind you that I will see you tomorrow. So you've got less turnaround time on the homework if you have any homework. So I will still accept today's circuit number 22 for full points. If I get it at the start of class tomorrow, that'll be under bell work. And the big long book assignment, assignment 20. Again, if you've been working on that, as I've been suggesting, you should have less than 10 questions to go, even if you didn't work on it in class today. So make sure you finish that up. That will be a 20-point homework assignment since it was longer. You're welcome to put it in the Google Classroom as you finished. It's already opened up. Or you can give me the hard copy tomorrow. But this is the third day that I've made it part of your agenda, so at some point we've got to move on. Friendly reminder that the book assignment or the book printout, I do need those back, so if you'd put those back in the basket on your way out. Again, if y'all start keeping those, then I can't keep making that many copies. We'll just have to use the books during class. And the books are perfectly fine, it's just they take up more of your desk space than the printout, so I just feel like that's easier for you. So feel free to continue on there. We've got about 7 minutes. But I will also share today's puzzle. I think I showed you this one last time. If y'all are on track with my second period. You did this one already? Okay. Did you do this one? Okay. So a little bit different. There's the daily puzzle if you want to mess with it.
Gave me 5 some.
Mm-hmm.
Is that because they're late?
Yep.
Because I didn't do all the way. I thought you said they were due today.
They're due at the start of class. You didn't give them to me at the start of class. Just like tomorrow, the circuit and book assignments due at the start of class. If I let you just turn it in any time during the day, then you're going to just try to finish it up during class and not pay attention to the next thing. I gotta have it at the start of class. Every time. There for. Anybody think they can do this well enough so you want to do it out loud for the class? I know John likes to volunteer. Have y'all ever seen that before? How your brain doesn't let you do it very well? I will say that I think y'all are my last class to see this one. I think 3 of my classes came up with a pretty good strategy to do it. Yeah, you're on the right track, yeah. They tried, a couple of my other classes figured out that at least people with glasses could just take their glasses off and then they can't read the word, but they can see the color, so your brain doesn't try to mess with you when you do it. And kind of the same idea if you tried to squint. If you squint enough, you can only see the color. Your brain doesn't get in the way.
So, for this one, secant T over T. I watched your video when you do it. Like, I did the quotient rule on that. But then you added a T over here. And I wonder, like, why you did that.
Okay, so when you do the quotient rule, you do the derivative of the numerator, and the derivative of secant T is secant T tangent T.
Okay.
Times the denominator left alone.
Oh, okay.
So it's just that part of the quotient rule.
Isn't the only way to have all of your values? Just asking if for this all of the values should be positive.
Correct. Which means your whole graph should be above the x-axis. But also, you want the derivative to be negative. So what's derivative same as slope? So you need your graph to be going down the whole time. Above the x-axis. Yep, that's possible. The function's positive the whole time, but the derivative is negative.
Yeah, so we actually more explicitly did not pull up. Automatically.
It's so lit.
Exactly.
Okay, you are down to about 2 minutes, so finished or not, you need to find a stopping place.